14, today's technical seminar on diaphragm walls and deep foundation, design, construction, and best practices. Friends, all of us know best practices. We have with us Dr. Jaykumar Shukla, Principal Engineer and Director, Geodynamics. Welcome you at Icea Surat with big round of applause. Limited, we have Mr. Yogesh Verma, AGM Quality and Production, Mr. Nikesh Maheshwarya, Marketing Manager, South Gujarat, Mr. Vinay Agrawal, South Gujarat Distributor. We welcome you with big round of applause at the Icea Surat. Thank you. On the onset, I would like to invite Engineer Pinak Desai, President ICEA Surat for welcome speech.
Everyone, it gives me a great pleasure as a President of ICEA to warmly welcome all of you for today's technical session. A very special welcome to Dr. Jaykumar Shukla, Engineer Ravikiran Vaidya, all the ICEA member, our sponsorer Kamdhenu Steel and their team, invited guests, all the past president of ICEA and all the professionals who has taken the time to join today's program. Today's topic is highly relevant to the construction industry, diaphragm wall and the foundation, design, construction and best practices. As our city grow, the project become taller and more complex. Deep foundation and underground construction are becoming increasingly important. Good design is essential, but equally important are proper construction practice, quality control, safety, and coordination between designer and contractor. We are fortunate to have a very experienced professional with us today. Our first speaker, Dr. Jaykumar Shukla, a Principal Engineer and Director of Geodynamics LLP, with his extensive experience in geotechnical engineering and deep foundation projects, I am sure we will get a valuable practical insight from him. We are also pleased to welcome Engineer Ravikiran Vaidya, a Principal Engineer at Geodynamics, who brings a strong practical and technical experience in his field. I am confident that their practices will help us to understand and not only the theory and design aspect but also the practical challenges faced at site, the best way to overcome them. I would also like to sincere thanks to Kamdhenu Steel for sponsoring today's program. Such program helps ICA to continue its effort to bring knowledge, technology and industry professional togetherness. I encourage all the members and participants to make the most successful session. Please feel free and ask questions, share your experience and discussion. Technical knowledge become more valuable when we share a practical experience with each other. Once again, I extend a warmly welcome to Dr. Jaykumar Shukla and Engineer Ravikiran Vaidya, the Kamdhenu Steel team, our all the past president and ICEA member. I wish everyone a very informative and productive session. Thank you. Without further ado, I request Dr. Jigar Sewalia to proceed with today's seminar. Thank you.
Is expression of love and gratitude towards our esteemed guest. Now, I would like to invite Engineer Pinak Desai and Mr. Yogesh Verma to felicitate our today's speaker, Dr. Jaykumar Shukla. Please come on the stage. Dipesh Bhai Shah to felicitate Mr. Yogesh Bhai Verma. But this time, our sponsors, I would like to mention the specific names of our today's sponsor: Kamdhenu Next Generation Interlock Steel and K2 Genox. So this is the specific names of our today's sponsors. Thank you. Proceeding ahead, we are starting today's seminar with presentation from Kamdhenu Limited team. I would like to invite Mr. Yogesh Bhai Verma to present.
आया था आपका एक्सपीरियंस लेने के लिए आया था, पर सारे गुजराती में बात कर रहे थे। मैं कहा मेरे लिए तो बेकार, मेरा क्या रहेगा क्या नहीं मैं समझूंगा नीचे जाके। तो प्लीज मेरा ये रिक्वेस्ट है कि आप सर जो बोलेंगे यहाँ पे आके, जो हमें सिखाएंगे, थोड़ा सा हिंदी भी यूज कीजिएगा या इंग्लिश अच्छा है, पर गुजराती सारी ना हो। चलिए मैं ज्यादा टाइम वेस्ट नहीं कर रहा। कामधेनु लिमिटेड कंपनी के बारे में आप सब शायद जानते होंगे। मैं पीपीटी नहीं लेके आया क्योंकि पीपीटी वाला वर्जन मुझे समझ नहीं आता। मेरे को तो बोर्ड वाला वर्जन समझ में आता है, बोर्ड अवेलेबल नहीं था यहाँ पे, तो कोई बात नहीं, हम बिना बोर्ड के थोड़ा सा डिस्कशन कर लेंगे। कामधेनु लिमिटेड कंपनी जैसा आप सब ने सुना ही है, सब जानते हैं, बहुत पुरानी कंपनी है। लगभग 31 साल की जर्नी है कामधेनु कंपनी की। 1995 में राजस्थान के एक छोटे से शहर भिवाड़ी डिस्ट्रिक्ट अलवर में पड़ता है, वहाँ से शुरुआत हुई। उसके बाद से कामधेनु ने जो विज़न लेके चली कि एक अच्छी क्वालिटी, एक बेस्ट प्राइस और अच्छी डिलीवरी के साथ में उसने अपना धीरे धीरे करके नेटवर्क ऑल ओवर इंडिया में बढ़ाया। और आज आप सब इंजीनियर्स, आप सब जैसे जो हमारी विद्वानों की जनरेशन है, उनके सहयोग से आज कामधेनु इतना बड़ा ग्रुप बन चुका है कि हम ऑल ओवर इंडिया में पर मंथ 4,70,000 टन के आसपास एवरेज में टीएमटी का सेल कर रहे हैं, जो कि रिटेल मार्केट में सबसे ज़्यादा है। प्राइमरी सेक्टर से भी ज़्यादा, जो प्राइमरी सेगमेंट वाले हैं उनसे भी ज़्यादा हम लोग टीएमटी बनाते हैं और बेचते हैं। बस एक थोड़ा सा ड्रॉबैक क्या आ जाता है कि प्राइमरी और सेकेंडरी एक दिमाग। भावनगर में छोटी छोटी मिलें होती थी, वहाँ पे शिप कटिंग जो आती थी उसको सीधा रेड हॉट करके रोलिंग मिल में से रोल करके और सरिया बनाए थे, उसको बोलते थे स्क्रैप का सरिया। एक्चुअल में स्क्रैप का सरिया वो है। उसने ऐसा बदनाम कर दिया इस शब्द को कि वो सेकेंडरी स्टील वालों के लिए कलंक सा बन गया कि यार आप लोग सेकेंडरी वाले हो, नहीं आपका तो बेकार है। अरे सर आप प्रोसेस तो देखो। जो BIS ने 1786 जो स्टैंडर्ड बनाया हुआ है वो सभी के लिए लागू कर रखा है, चाहे वो प्राइमरी सेक्टर हो चाहे वो सेकेंडरी सेक्टर हो। अगर IS 1786 का लाइसेंस आपके पास में है तो आपके स्टील में और प्राइमरी स्टील में कोई फर्क नहीं है। आप ही के उसमें जनरेशन में से सन 2014 की बात मुझे याद आ रही है कि जब हमने कामधेनु SS 10,000 हम लेके आए थे। मई 2013 में हम कामधेनु SS 10,000 लेके आए थे। कामधेनु SS 10,000 क्या था? एक नाम था। कामधेनु ने सरिये की लाइन के अंदर में बहुत R&D करी है, क्योंकि अगर मैं प्राइमरी सेक्टर की बात करता हूँ, मैं किसी एक पर्टिकुलर कंपनी का नाम नहीं लूँगा, कोई भी प्राइमरी सेक्टर वाला है उसके पास में कई प्रोडक्ट हैं करने के लिए, वो अपने कंपनी को, अपने ग्रुप को बढ़ाने के लिए बहुत से प्रोडक्ट यूज़ करता है, पर हमारे पास केवल TMT था। उस टाइम की बात है जब हमारे पास केवल टीएमटी था। तो हमने एक R&D सेक्टर डेवलप किया इसमें, और टीएमटी में हमने देखा कि हम क्या डेवलप कर सकते हैं। केमिकल प्रॉपर्टीज जो मैं बना रहा हूँ वो प्राइमरी वाला दे रहा है, या जो प्राइमरी वाला दे रहा है वो मैं भी बना सकता हूँ। फिजिकल प्रॉपर्टीज जो प्राइमरी वाला दे रहा है वो मैं भी दे सकता हूँ। तो मैं उससे अलग क्या दूं? थर्ड नंबर पे आता है रिप डिजाइन। रिप डिजाइन एक इतना मतलब ऐसा सेगमेंट है जिसके ऊपर किसी ने काम नहीं किया। कामधेनु 2013 में, मई 2013 में हमने लॉन्च किया SS10000। सुनने में वर्ड थोड़ा वैसा आता है कि यार SS10000 का क्या मतलब है। उस टाइम जब हमने इसकी मार्केटिंग चालू करी तो मार्केट में लोग बाग बहुत हंसी उड़ाते थे। एक अपने यहाँ तो खैर ड्राई एरिया है, नहीं तो 10,000 वर्ड जिसके साथ आता है आप सबको पता होगा कुछ को। तो सब कहते थे यार 10,000 क्या आएंगे। एक्चुअल में इसका जो कहानी थी वो ये थी कि कामधेनु कंपनी का नाम हो गया, ब्रांड नेम है। SS स्टेल सुपर स्ट्रेंथ, सुपर स्ट्रॉन्ग, कुछ भी मार्केटिंग वर्ड में बोल सकते हैं। 10,000 वर्ड हमने लिया कि जो सीमेंट कंक्रीट की कंप्रेसिव स्ट्रेंथ देखते हैं, आपको सारा पता ही होगा नॉलेज कि सरिये में हम लोग टेंसाइल स्ट्रेंथ चेक करते हैं और सीमेंट कंक्रीट में कंप्रेसिव स्ट्रेंथ चेक करते हैं। तो जो बेस्ट सीमेंट कंक्रीट की कंप्रेसिव स्ट्रेंथ होती है जो हाई राइज बिल्डिंग्स के लिए यूज करते हैं, मैक्सिमम वो 10,000 PSI की लेते हैं, 10,000 पाउंड पर स्क्वायर इंच। तो हमने फिर वहां पे लोगों को एजुकेट करना चालू किया कि 10,000 वर्ड का मतलब ये है। तब धीरे धीरे लोगों को समझ में आया। उसमें जो एक डिफरेंट था वो था उसका रिप डिजाइन पैटर्न। रिप डिजाइन पैटर्न, आई एम सॉरी मेरे पास में यहाँ पे बनाने के लिए है नहीं, पर आप स्टील पे अगर देखेंगे, आवाज आ जाएगी थोड़ी सी। ये जो रिप डिजाइन पैटर्न है, डबल एंगल, दोनों का रिप डिजाइन अलग है। दो रिप्स है, एक 70 डिग्री पे है, एक 54 डिग्री पे है, या एक 65 डिग्री पे है, एक 48 डिग्री पे है। इसका भी एक पैटर्न लिया गया। एक्चुअल में देखिए हम लोग जो भी कॉपी करते हैं यूरोपियन कंट्रीज की। हमने इस डिजाइन को यूरोपियन कंट्रीज से कॉपी किया क्योंकि ये डिजाइन ऐसे ही नहीं बनाया गया। इसकी थीसिस पूरी हमारे पास में है। हमने 2 साल इस पे R&D करी, इसको बनाया, इसके सारी टेस्टिंग किए। फिर IIT रुड़की से, IIT दिल्ली से जब इसका हमें पुल आउट टेस्ट के रिजल्ट बढ़िया आए, उसके बाद हमने मार्केट में इसे लॉन्च किया। तो इसका जो भी जब हमने लॉन्च किया उसके बाद में लोगों की ये एक्सपेक्टेशन आई कि यार ये है क्या, क्यों बनाया आपने ऐसा। तो उसी दौरान मेरे पास एक फ़ोन आया जब हमने लॉन्च किया। बीकानेर राजस्थान में पड़ता है, वहाँ पे एक मैं फ़ोन के ऊपर था, मुझे पता नहीं था कि वो सामने वाले जो आर्किटेक्ट सर हैं वो किस उम्र के थे, पर उनका जो पहला सवाल था उसके हिसाब से मैं लगा सकता हूँ कि हाँ वो ओवर 60 होंगे। उन्होंने कहा बेटा मैं आज तक प्राइमरी स्टील को यूज़ करता रहा हूँ, आज आपके मार्केटिंग हेड आए हैं मेरे पास और ये कामधेनु SS10000 को प्रमोट कर रहे हैं, तो आप मुझे टेक्निकल वर्ड में सिर्फ एक लाइन में बताइए कि मैं प्राइमरी को छोड़ के कामधेनु स्टील क्यों लूँ या SS10000 क्यों लूँ। एक वर्ड में बताइएगा, मार्केटिंग वर्ड नहीं होना चाहिए। तो मैंने उन्हें सिर्फ एक ही चीज़ बोली, मैं कहा सर अगर प्राइमरी वाली केमिकल कंपोजिशन, प्राइमरी वाली फिजिकल प्रॉपर्टीज और प्राइमरी वाले डिज़ाइन से बेहतर डिज़ाइन, बेहतर बॉन्डिंग स्ट्रेंथ अगर आपको कम दाम में मिल रही है तो आप क्यों ना लें, आप मुझे बताइए। बस उसी बात के ऊपर हमारी डील साइन होगी। क्योंकि मैं मार्केटिंग नहीं जानता, मुझे नहीं आती बातें करनी, मार्केटिंग सर जानते हैं, निकेश जी जानते हैं। तो इस डिज़ाइन को लेके जब बात हुई तो उन्होंने कहा ठीक है मैं मान गया आपकी बात, ये डिज़ाइन कहाँ पे बनता है। फिर मैंने उन्हें दिखाया स्टैंडर्ड में, कहा जी ब्रिटिश स्टैंडर्ड में इस डिज़ाइन को बाकायदा एक स्टैंडर्ड दे रखा है। जैसे अपने यहाँ इंडियन स्टैंडर्ड में जो हमारे ग्रेड्स हैं, कोई बता पाएगा एनीवन कि इंडियन स्टैंडर्ड में जो हम TMT बार यूज करते हैं उसमें कितने ग्रेड हैं? एनीवन, एनी गैस? पार्डन? 7? आगे सर कोई? 3? सिर्फ आपकी एक नॉलेज के लिए मैं बता रहा हूं कि आज की तारीख में, जी मैडम आप कुछ कह रहे थे, बोलिए, ओपनली बोलिए। हाँ देखिए सर, मैं आपसे सबसे रिक्वेस्ट करूंगा कि आप सब एक स्ट्रक्चर का डिजाइन करने वाले, मतलब एक विश्वकर्मा, भगवान विश्वकर्मा के एक मूर्त है। भगवान विश्वकर्मा जो मतलब इस सृष्टि के रचयिता हैं, आप उन्हीं का एक छोटा सा अंश है कि आप सबके घरों का, सबके सपनों को बनाते हैं, बुनते हैं। इंसान 90% इंसान, हमारे जैसे इंसान जो सेकेंडरी वाले आते हैं, वो जिंदगी में केवल एक बार घर बनाते हैं और अपना सब कुछ लगा के, दाव लगा के बनाते हैं। तो आपसे, आपके पास आएंगे, आप अच्छे से अच्छा उन्हें डिज़ाइन बना के देंगे, आप अच्छे से अच्छा उन्हें स्टील सजेस्ट करेंगे, अच्छे से अच्छा सीमेंट सजेस्ट करेंगे। ये मैं प्रैक्टिकल एक बात बोल रहा हूँ, मेरे साथ हुआ, फेस हुआ ये। जब हमने SS 10,000 बनाया, हमने बहुत अच्छे से अच्छा बनाया। पहली गाड़ी जब निकली तो जयपुर में एक डॉक्टर का घर बन रहा था, तो पहली गाड़ी में शिकायत आ गई। कंस्ट्रक्शन साइट से फोन आया कॉन्ट्रैक्टर का कि साहब आपके स्टील में हार्डनेस है और दिक्कत आ रही है, आप आ जाओ साइट पे। क्योंकि हमने लॉन्च किया पहली बार, या इतना अच्छा सरिया लॉन्च किया है, IIT ने अप्रूव किया है डिज़ाइन को, उसमें शिकायत कैसे आ गई। मैं वहाँ पहुँचा, नेक्स्ट डे पहुँचा, और वहाँ जाके मैंने देखा, साइट पर विजिट किया, तो 5-6 बंडल 16 mm के, 8 mm के थे। बंडल के कड़े लगे हुए थे, कुंडे लगते थे वहाँ पे, वो खुले भी नहीं थे। मैंने वहाँ पूछा जो लेबर थी, मैंने कहा यार ये शिकायत करी है किसी ने कि भाई हार्ड है मटेरियल। बोला हाँ बाबूजी हमने शिकायत करी थी, वो जब ट्रैक्टर में से माल नीचे गिरा है ना तो छन छन की आवाज़ नहीं आई, वो धम धम की सी आवाज़ आई, तो हार्ड सा है मटेरियल। मैं कहा यार मैं समझा नहीं भाई, आपने मतलब बंडल को खोला नहीं है और बोला भाई साहब जितनी आपकी उम्र है ना उससे ज़्यादा एक्सपीरियंस है। मैं कहा चलो बाबूजी मान लिया आपकी बात, मेरे उम्र से ज़्यादा एक्सपीरियंस है, पर मेरी उम्र से ज़्यादा जो एक्सपीरियंस है आपको, वो ये स्टील का नहीं है ना। आप जब से मोड़ते आ रहे हो, जब से केवल राउंड बार बनता था, रिब्ड बार बनता था, या CTD बार बनता था। TMT तो अब चालू हुआ है 2004-5 के बाद में, इंडिया में तो TMT था ही नहीं उससे पहले। तो ये बोले नहीं जी ऐसा है कि ये मटेरियल हार्ड है, आप शर्त लगा लो। तब मुझे बहुत वो लगा, बहुत फील हुआ। मैंने कहा यार देखो हमने अच्छे से अच्छा बनाया, मतलब हमारी टीम जो इंजीनियर्स की टीम थी उनकी मेहनत सारी की सारी अच्छी थी। जो आर्किटेक्ट इंजीनियर्स थे जिसने सजेस्ट किया, ऑनर को सजेस्ट किया कि आप ये वाला सरिया लगाइए, ठीक है, उन्होंने अपनी मेहनत लगाई। और मेरी टीम की, आपकी टीम की मेहनत किसने फेल कर दी? एक जो इलिटरेट पर्सन वहाँ पे कंस्ट्रक्शन साइट पे है, वो क्या कहता है कि भैया मटेरियल आपका हार्ड है, बेकार है, हटाओ, हमें नहीं चाहिए। सिर्फ किस लिए? क्योंकि उसने मटेरियल की आवाज़ ऐसी सुनी कि छन छन नहीं आई, धम धम करके आई आवाज़। अब उनको आदत क्या है, ये प्रैक्टिकल है सर, 90% बल्कि 99% केसेस में हम ये डेली फेस करते हैं। मटेरियल की शिकायत आती है साइटों पे से, आप सजेस्ट करेंगे ये वाला मटेरियल लीजिए, अच्छा कॉन्ट्रैक्टर होगा, पढ़ा लिखा होगा, सिविल इंजीनियर होगा, पर काम किससे करवाएगा? लेबर से करवाएगा ना। लेबर को जानकारी नहीं होती। लेबर को जानकारी देने के लिए फिर हमने मैसन टू मैसन मीट करवानी चालू करी, कॉन्ट्रैक्टर मीट करवानी चालू करी, अब भी कर रहे हैं, रेगुलर बेसिस पे कर रहे हैं। पर हमने ये देखा कि यार कम से कम हमारे इंजीनियर्स को भी हमें बेसिक्स तो पता होना चाहिए। TMT एक ऐसा मतलब ऐसी चीज है सर इमारत के अंदर जो बैकबोन का काम करती है। हमारे शरीर में जो काम रीढ़ की हड्डी का है वो मकान में TMT का है, क्योंकि हम सब कुछ चेंज कर सकते हैं। मकान का रंग चेंज कर सकते हैं, टाइल चेंज कर सकते हैं, फर्श चेंज कर सकते हैं, लाइटिंग चेंज कर सकते हैं। TMT चेंज करने के लिए मकान ही तोड़ना पड़ेगा जी आपको। तो इसलिए मैं आप सबसे यही रिक्वेस्ट करूंगा कि अगर किसी को भी सजेस्ट करें अच्छा स्टील, तो साथ में ये भी सजेस्ट करें कि आप कौन से ग्रेड का सरिया लगाओगे। क्योंकि आज भी मैं नहीं समझता, मैं बहुत जगह जाता हूँ, मैं पूछता हूँ, आज भी मार्केट में केवल देखा देखी एक रेस चल रही है। जो मैंने ग्रेड की बात करी थी, मैं उसको कंप्लीट करता हूँ एक बार। इंडियन स्टैंडर्ड में आज की तारीख में 11 ग्रेड है, 11 FE 415, FE 415D, FE 415S, FE 500, FE 500D, FE 500S, FE 550, FE 600, FE 650 और FE 700। ये जो इसमें सॉरी डी ग्रेड भी है, 550 में भी डी है। तो ये जो 11 ग्रेड्स हैं इनका मैक्सिमम लोगों को नहीं पता। मार्केट में क्या चल रहा है, 550 चाहिए जी, या 550D चाहिए जी? क्यों चाहिए? किसी को 1 मंजिल घर बनाना है या 2 मंजिल घर बनाना है, क्या उसके लिए 550 ग्रेड अच्छा रहेगा? उसको यूज करना चाहिए। और अगर करना चाहिए तो क्या 500 की जगह 550 अगर वो यूज कर रहा है, क्या स्टील की क्वांटिटी कम होगी? ये सब जो कैलकुलेशन है सर, ये जनरल आदमी को नहीं पता, ये सब आपको पता है। और मैं आज इसी उम्मीद से आया हूँ कि मुझे भी कुछ ये चीजें सीखने को मिलेगी, क्योंकि डिजाइनिंग का एक सेशन है यहाँ पे। तो प्लीज मेरी आपसे हम्बल रिक्वेस्ट है कि आप सब अपने फोन के अंदर में पीडीएफ डाउनलोड कर लीजिए, IS 1786 1786 जो हमारा BIS का स्टैंडर्ड है TMT के लिए, उसमें सारी चीज क्लियर दे रखी है। क्योंकि जैसे जैसे ग्रेड बढ़ता है वैसे वैसे स्ट्रेंथ बढ़ती है, स्ट्रेंथ बढ़ती है तो उसकी डक्टिलिटी कम होती है, इन्वर्सली प्रोपोर्शनल होते हैं। और जब डक्टिलिटी कम होती है तो लेबर जो काम कर रही है उसको मोड़ने में जोर लगता है। तो जब मोड़ने में जोर लगेगा ना, तो क्या कहेगा, हार्ड है मटेरियल बाबूजी, खराब है। तो आजकल वैसे ये भी अच्छी बात है, बड़ी बड़ी साइटों पे तो आजकल बेंडिंग मशीनें यूज होती हैं जिन पे मेंडल्स वगैरह लगते हैं प्रॉपर, पर उसमें भी प्रॉपर मेंडल यूज नहीं होता। 25 mm का सरिया मोड़ना है, वो 10 mm का 20 mm का मेंडल लगा हुआ उसी में मोड़ना है जी। 20 का मोड़ना है वो भी उसी पे। हम तो 25 सालों से 30 सालों से ऐसे ही करते आ रहे हैं जी। अरे साहब 30 साल पहले TMT बार ही नहीं था, ग्रेड ही नहीं थे, स्ट्रेंथ ही नहीं थी, नरम सरिया होता था। सरिया एक तरह की कॉमोडिटी होता था कि हमें तो केवल सरिया लगा, लोहा लगाना है यार, कोई सा भी लगा दे, जो सस्ता है वो लगा दे। पर अब लोगों में अवेयरनेस हो रही है, तो हमें भी, हमारी ये मोरल ड्यूटी है सर कि हम लोगों को बताएं कि आप अच्छी क्वालिटी यूज करें, बेस्ट क्वालिटी यूज करें, जो आपके पास में इजीली अवेलेबल है वो यूज करें। तो इसके साथ में एक दो पॉइंट लिख के थे मैंने, पूछूं एक बार। हाँ, इसके साथ में जो रिडिजाइन की बात कर रहा था, ज़्यादा टाइम तो नहीं लगेगा क्योंकि मेरे को मजे आते हैं बोलने में, आप लोग बोर ना हो, देख लीजिएगा। रिप डिजाइन की जो बात कर रहा था, इसमें रिप डिजाइन में हमारी जो यूएसपी बोल सकते हैं, हमारी यूएसपी ये थी कि इसमें जो बॉन्डिंग स्ट्रेंथ थी, नॉर्मल टीएमटी के लिए जो बीआईएस की रिक्वायरमेंट है 80%, वो हमारी निकल के आई थी 254%। तो लगभग 2.5 गुना ज़्यादा निकल के आई थी बीआईएस की रिक्वायरमेंट से। इसलिए हमने यूएसपी बनाया इसको कि जब हमारे शरीर की पकड़ इतनी अच्छी होगी, और अगर आप जैसे SS 10,000 जो वर्ड यूज़ किया था कि बॉन्डिंग स्ट्रेंथ हमारे वाले डिज़ाइन से हो, और सीमेंट कंक्रीट की जो कंप्रेसिव स्ट्रेंथ है वो SS 10,000 वाली PSI की हो, तो जो बिल्डिंग बनेगी उसकी मजबूती की कोई सानी नहीं होगी। आई थिंक मैं अपने वाणी को रेस्ट देना चाहूँगा। अब अगर आप लोगों को कोई क्वेश्चन है TMT से रिलेटेड तो प्लीज हैव ए आस्क। थैंक यू।
Thank you very much, Yogesh bhai, for sharing information, experience, and emotions about the product, and information about the company. It was really worth listening about it. Thank you once again. Proceeding ahead, now I would like to invite my friend, my team member, Engineer Jaykumar Shukla, to introduce Dr. Jaykumar Shukla.
Present here. It's a pleasant coincidence that I, Engineer Jay Shukla, having opportunity to introduce Dr. Jaykumar Shukla. Dr. Shukla is a highly accomplished geotechnical engineer with more than 22 years of professional experience, having worked on several challenging assignments involving deep foundations, ground improvements, slope stability, and geotechnical instrumentation. His expertise spans a wide range of projects including power plants, ports, high-rise towers, tailing dams, dam safety evaluation, large-scale foundation projects, and mega bridge projects. He has held key positions with reputed organizations including L&T, Sargent and Lundy, Royal Haskoning, and SR Steel. He was also a recipient of the University Gold Medal during his Bachelor of Engineering Studies and earned his PhD from IIT Bombay. Dr. Shukla has made significant contribution to the field through his professional and academic involvement. He He has been executive committee member of the Indian Geotechnical Society since 2018. He is also actively associated with ISS, MGE technical committees and is a member of the Civil Engineering Division of the Bureau of Indian Standards. He currently serves as convener for IS 6403 on bearing capacity of soil and co-convener for IS 2911 on pile foundations. He is also actively involved in research and development with more than 30 research publications in national and international forums. He serves on academic boards at the Maharaja Sajirao University of Baroda and Charodar University of Science and Technology. With his rich blend of industry experience, academic excellence, research contribution, and expertise in geotechnical engineering, we are truly fortunate to have him with us today. Dear members, please join with me in welcoming Dr. Jaykumar Shukla.
To share so many things over here. This is regarding diaphragm walls and designs and other things. There are many friends over here, and I would specifically thank Kamdhenu for reinforcing us in an activity like this, where we exchange the views and perspectives and learnings. So thanks for supporting ICAI and such activities, and we hope that you will continue doing these things again and again for this fun. And at the same time, I would also thank ICAI members and their, let's say, committee members for specifically inviting me and Ravikiran over here for sharing this on diaphragm walls specifically. There is plenty of slides over here. However, I would like to do it in bit informal ways. There is nothing like so specific that we will only continue into English. So I just would like to have one-to-one conversation with many of you who has questions and who has some insight or would like to discuss something. And that's why if you see, I have made one topic or let's say the title of a presentation as engineering discussion. So for that matter, probably there are plenty of things we see or I see from a different perspective, and probably you might have seen from different perspective as well. So we will go one by one. We'll try to evaluate some situations and then we'll try to take a learning out of it so that we all remain on the same page when any of the design or any of the diaphragm wall construction activities will be coming to you. So let's go. Yeah, it's there. Yeah. Okay. So I hope this particular is a bit familiar to you. I think I think all those who are into Surat know what is happening into many of the sites across Surat. Yeah. So this is one compound wall collapse near Shiv Residency. I don't name the site. However, probably the rectifications and other things are going on, which has been already over. I think the previous year this has been addressed. This is the same picture, same site, and then this was another, I think this is this year, and this was one particular site where the cars have been collapsed, and you might be knowing better than me that how many of this kind of accidents or incidents has been happened in recent or few years of the time in Surat and around the region. Earlier, there was not much reported from Ahmedabad, but from this year, we could also have many of other projects of similar situation reported from Ahmedabad as well. I probably can count it because many of the sites, though I am not involved into their design, but when such incidents happens, almost, let's say, many of the cases have been then invited to restore the things and then make things happen so that builder can construct in an appropriate way. So all this experience which probably we are sharing, is based on those kind of experience. Now let us go about, I hope the screen and things are visible to it. The main important aspect is you see the line of the diaphragm wall or secant pile wall or whatever you can say. And then you can see the tilting. Right? Okay. I hope. You see this carefully. You see the spark. And many of collapse. Right? So we will not talk about the collapse, why it has happened and what has happened. But we need to take a learning out of it, what went wrong. And probably when you go back and design those things, probably it should not happen again. Or maybe a small check or minimum careful evaluations probably will save you out of such kind of failures. I would say failure because many of the things are in control of the engineers, which at that point of time probably we might have missed or avoided or ignored. All are clubbed one, and then this kind of incidents has happened. Now, if you see that since the Indian standard do not have a appropriate document which talks in detail about the design of diaphragm walls and embedded retaining walls, and in that case we have a specifically international standards. Three standards I would name it. One is the Syria guidelines for retaining wall design, then another Syria report 104, and then the Syria report 77, which three are the key document. Those who are probably want to address, want to go penetrate further into design of this embedded retaining wall or diaphragm wall, this document should be on their table for further design. Let us go it. Now, as a geotechnical engineer, because you might have been practicing from structural engineer's point of view, some let's say some friends would be looking from the architecture's point of view. But when we see from the geotechnical point of view, who actually deals with the design of diaphragm wall, even construction of diaphragm wall as well, what are their concerns? So I just listed out some of the concerns over here. What questions we need to answer is, what are the in situ conditions in terms of subsoil conditions? So you will definitely go for geotechnical investigations, and then probably the investigation agency will give you a soil report. And into that soil report, there are some soil properties which has been listed. The support system, whether you will go with anchors or whether you will go with the bracing, or are they sufficient in numbers, or they are sufficiently stable or not. So that is need to be questioned, or probably need to answer those things. Then is excavation stable during each stage? This is very important because we will go with some sequencing, and we will try to understand that which is the sequence which is more critical about it. Then adjacent structures, this is very more and most important part, because the adjacent structures actually influence the way you do it. And then the surcharge, which everybody understands, that surcharge from the adjacent building to the diaphragm wall is very, very important to understand. And most of the cases people try to ignore it because they may not have all the information in hand, but that particular is more important to. Then any individual anchor is overloaded. This is a bit a design aspect which a design engineer will do into their office, and then they have to answer it that if one anchor fails for whatsoever reason, then what will happen and what are the consequences. It's just like in a building design, if you have plenty of columns supporting to the floor, and then if any one particular column fails for whatsoever reason, then whether the building would be still able to survive or not. And that's particular more important into it. And then the distribution of loads in support system, which means that whether you go for anchors or bracings or any other thing, whether the supports are probably loads are into reasonable or not. I have some let's say design or probably seen design with the anchor forces goes beyond 50 ton to 80 ton. And even if you go into the soils, probably in Surat, I do not see that we install rock anchors. But in Mumbai, probably you will go and there are plenty of rock anchors has been installed. But in case of let's say Surat, we hardly use with the soil anchors. So in that case, the anchor force or allowable load or an anchor load should not go beyond X limits. If you go with the any of the unrealistic limits, probably your excavation system would be unstable. And there are plenty of reasons to this. And then what are the conditions and influence of ground water table? This is the most critical and mostly missed part of sorry for that. Is there any excessive bottom heave? I am not sure whether probably has been there. We will go and see some cases. What is the long-term performance of deep excavation system? So sometimes it happens that we think that we will construct in 2 months time, 3 months time, but then somehow the project got extended, and those things which you believe that you would be able to do it within before monsoon, that got extended, and then now everybody is in trouble because some design assumptions goes wrong and your construction sequences are wrong or inaccurate, and that's what probably the thing is. Okay, let us try to understand what is happening and what you have seen till date. What happened when the diaphragm wall deflects? The deflection shape is not always going from the let's say from the top. It should not be like cantilever. It would be all depends on the support system which you have understood employed. That means how many number of anchors, what is the construction sequence. Probably we will have one particular small illustration about it so that I will be able to make you understand from this forum that the sequence of your construction is very, very important. And believe me, just like a soil, the soil remembers what you do to it. Probably whether you do it in backfilling or you do it in excavation, but each stage the soil remembers everything what you do at site, whether in front of diaphragm wall or at the back of the diaphragm wall. So that particular is very much important to understand. And generally, let's say if we see this figure, this is coming from the long-term observations, be it from Terazaghi and Scantons or whatever the big scientists you name it. Everybody thinks that it should be like this. Now, if my diaphragm wall is here, and I would like to understand that on the back of it, how much the influence is to be generated when I excavate it. If that influence is known to me, probably any structure coming within that influence, I'll be more careful. If I don't know that extent, that how much is the influence, probably I may be ignoring something, and that particular will create a later on issues. So I will just keep this and come to this particular point. Now, in this context, there is one diaphragm wall which is having 2 anchors, and that anchor is approximately excavated up to 30 meter, and I need to give some sufficient depth from here to inside so that there will be a base resistance or anchor below the excavation level. There is a support. Many of you are structural engineers or civil engineers. It's just like we have a vertical beam. It has been supported at this location by some X reaction, this location by Y reaction, and then there are some passive resistance generated over here which would be supporting this vertical beam, which you will be able to analyze using STAT, ETAPS or whatever you can understand, that you will be able to do it. However, the crux is how much load you will think that this would be generated as active wedge, and how much the resistance you will get it from passive resistance. What if this particular embedment below this is not sufficient? Now, one case I would like to highlight in one of the site, when the design has been given to the designer, they only mention the top of the basement. No, they did not mention the thickness of the footing or thickness of the raft. So the designer issued that design, and then this has been already constructed. Now later on, the contractor goes on excavating for the footing, because they has to do the PCC, right? So they excavated 1.5 meter to 2 meter additional from the top of the basement, and that has breached the minimum requirement from this point to this point. What will happen? Your anchors and everything would be stable, and this diaphragm wall has been came inside from there, and the site was entirely got collapsed. One major building at the back of it has been distressed, and the entire site has stuck up for 1.5 years. The builder has to construct another building first, because that was the requirement from the authority, and then you have a, let's say, barrier wall, and then you will go further for excavation. And it was just a little bit one miscommunication. That's what I understand, because the originator from the design or from the structural engineer, when you specify the excavation depth, you should not specify the excavation of your basement level. You should specify the bottom of your PCC level, and that's what would be the key particular aspect. So I would request that from all of you, from today onwards, whenever you communicate your basement sections to any of the designer, probably please specify what would be the bottom of your PCC rather than top of your basement level, because that thickness is one of the governing distressing criteria when this particular kind of incidents are happening. Okay, let us move on. Have you seen this kind of a creek? How many of you have seen such cracks in the back of your diaphragm wall? Let's say if I ask you one question, whether these cracks are serious or not, and probably I would like to understand why these cracks are, that particular is very much important to understand why these cracks have been there. Okay, let us go further. This is nothing but you have a one diaphragm wall, and the soil just adjacent to it has got crack on the top. You will see from this particular crack, after 2 to 3 meters, you will be again have a one horizontal crack all along the parallel to diaphragm wall. And this particular is a starting point, or I would say it is showing you that your diaphragm wall system has some problem. And sometimes you miss because nobody goes on the top and see at the back. I hope so. Whenever you got a chance, whenever you are designing your diaphragm walls, if the basement depth is more than 2, that means if you are targeting 3 basements, always ask your engineer to have a surrounding check and see for this kind of a crack. This is the first origination point which you need to remain careful, that this kind of a crack should not be there. Now what will happen if this would be extended into the houses? And probably many of you might have been experiencing small houses on the back of the diaphragm wall. They are nothing but the let's say the result of the settlement which has been going to be back place, because when the diaphragm wall excavation goes on, this wall is going to deflect, and accordingly you will have settlements on the back, and any of such kind of a floor finish or finish probably cannot survive into such small cracks. So these are also one indication that settlement is going on. Now there are plenty of things. You just see this one video. You see? I hope the things are clear at the back as well. No? How many of you have seen this kind of a boiling close to your diaphragm wall in any of your projects? You might have been seen, but many of the time people say, oh, okay, nothing, kuch nahi ho jayega. Right? So, and then you can see like this, same. And this is one of the key second observation. Keep in mind, if these situations are there, which is more likely that you will be having a high groundwater table at the back of the wall, and when you have excavated, you have removed the surcharge. So now there is a quicksand condition, or whatever you can say, that has been occurred at the basement level excavation. And this would probably, sorry, we'll go back, and this would probably is happening some issues with the passive resistance which has been there over here, which means that there is no passive resistance is now within the zone where this boiling has been occurred, and this beam which you are analyzing that it will have some support from here, that support has been breached, and that means you have a high chances that the wall will give up maybe in no time, because then the failure is catastrophic. You will not be able to control it, because you will be able to control something at the top, but if wall is starting moving from the base, you will not be able to control. And we will see what particular is general cause at the later date into that case. And I have seen some of the soil which is coming out from the base and then emerge out on the let's say inside of the pit, and still people feel that okay, it's okay, chalta hai. Now, okay, it's fine. Sometimes you take up chances of it, it's fine. But imagine that this kind of a soil volume has been came out from somewhere, and that volume displacement or soil erosion, what you can say, or particle migration is creating a void somewhere, and that particular is nothing but the path which has been established by the water to emerge from the inside of the excavation, and that creates an issue, because once that path has been established, probably it will be difficult to regain all the soils which has been there into the place. So the differential water pressure is one of the key criteria. Never ever ignore those things, right? Okay. Okay, we will see another one. This is from Surat site only. Yeah? Now, imagine that you have gone to the site and these things are happening. What would be your first action and reaction? શું કરશો? કઈ નહીં, તો એનું કામ તમે કરવા દો. એન્કર, if I will be anchor contractor, હું શું કહીશ? સાહેબ એવું તો ચાલા કરે, તો કઈ નહીં, હમણાં ગ્રાઉન્ડ કરી દઉં, એન્કર નાખીને ગ્રાઉન્ડ કરી દઉં. So you can see this entire heap has been came up from that particular hole and keeps on coming. Now imagine at the back of it. Now soil has been displaced, a big particular volume of such heap has been displaced from the back of the diaphragm wall, came inside of your wall. What will happen to the utilities or the facilities which is supported on the top of your diaphragm back? What will happen? સીધો સાદો હિસાબ છે, એમાં કઈ સેટલમેન્ટ થશે, crack પડશે. However, this crack you will not see immediately. This crack you will see after some time, because there is a big volume at the base, and that volume will adjust based on something has been expected out, and that response time would maybe 2 days, 3 days, 5 days, or 1 week. By that time, the contractor might have already grouted, and then you try to see, "Arey sir, kuch ho gaya." Contractor say, "Nothing. I have already grouted everything. Anchors are fine. You see, load bhi le raha hai." But the damage, whatever has been happened, that has been already done. Now you will not be able to rebuild it. The crack is going to come, and all your facilities at the back has to crack. You just have to wait and watch how the ground is going to respond. You will not be able to even grout it also. Nothing you can do. What you can do is, at a time of construction, your supervision should be careful. So that probably is one important aspect you should do. Whenever you do, and this is more frequent and recurrent in Surat, because whenever you do the anchors through very fine silty sands or fine soils, this is very frequent. The soil keeps on coming from the anchor hole, and that guy keeps on drilling again and again, but more volume coming out from the anchor hole, which is actually not good for the back, which is going to respond to you later on. But itna kaun dekhta hai? Right? So now there are some particular issues with diaphragm wall construction itself. Whether you will be able to, let's say, or I would say, accept this as your own home and support system, probably not. But sometimes it is too difficult to convince everybody that this particular is a good diaphragm wall, where I could see that there is nothing like a wall at all. No? There are plenty of cavities, plenty of honeycombing, and now your diaphragm wall. Imagine the designer like me will cry if you say that this is your diaphragm wall and your support system is like this. Even if you support anything, probably the wall itself will not take this. It is a local failure of the wall. It's not the support which is failing, it's not the main structural, or not like a Kamdhenu still is failing. It's just like a, what particular is failing is like the element itself, right? So, okay, one of the case which I saw, the failure case where I have been advising them, what has happened is they have a big running utility or drainage, let's say, I will not say canal, but the drainage has been going exactly from the back of the diaphragm wall. And the guy who knows actually, because the main hole is very, let's say, visible at the back. And they also know that in every monsoon, this drain or this particular, let's say, the drain is running full. Now, when anything you construct at the back of the diaphragm wall, then you excavate 8-10 meter, and imagine that this wall is not going to displace is impossible. So even if anybody would like to show it to you in SAP or whatever the software they are using, that there is no deflection, bullshit. Don't remember or don't particularly rely on it. The wall has to deflect, and wall will deflect, because without deflection, probably your anchor also is not going to get the reaction at all, because if unless we move it, probably the anchor will then and only then will take a reaction. So wall has to deflect. When the wall will deflect, the first crack will occur, whatever has been there at the back, and if any drains would be there, they are going to crack. And imagine if the drain has been cracked, the leakage which has been coming from that running full drain, your diaphragm wall is about to collapse, that's for sure. So I think many of incidents, even I in Surat also see that similar kind of a situation has been there, that somebody is pumping from their pit, putting everything into one drain. The drain is running full. It has been cracked because someone has already excavated 12 meters, and now from that crack, that all the water has been seeping behind the wall. And for that matter, pore pressure is too high. None of your design or diaphragm wall has been designed corresponding to it. If you ask a designer, they will say that I have just seen the the water table from the soil report, and it says that the groundwater is 8 meter, 10 meter, but now you have a different problem. And within the no time, your wall is going to crack, you are going to break. So be careful when you have a diaphragm wall running at the front of your main road and main trunk drain. If it is there, probably you need to do so many things. And sometimes I could see that many of the people are dewatering it, but again it will come down to the same site into that. So they are just spending more and more efforts only into dewatering, and then water has been recycled. So the same case happened in no time, because the morning we visited, I said that your wall is going to go, and by the time I boarded the flight, everything has gone. And that's what probably I could see, that the water is one of the main and key culprit. This is one site which probably one of my friend knows, or he also knows. It's not important which site it is. It's important that what has happened, and that particular is. Sometimes we design cantilever retaining wall or cantilever wall, but what has happened? Some crack. What we can see that, as I said, I earlier gone into this. Just a moment. Such cracks. These cracks, they originated when you have excavated. Now imagine that there will be one thunderstorm, and probably, sorry, oh, no, it's dynamic, so that's why it is running. Maybe next monsoon, all the water goes behind your water, and believe me, we all are engineers and we work into the same profession. Have a hand on your heart and say, it was whose fault? કોનું ભૂલ છે? Who, the people who has designed, or the person who has been, let's say, routing the trench, or I would say the canal or a drain, or the corporation itself, because they do not have a sufficient drainage. So all the water which has been accumulated on the road now came and, let's say, seeped into the back of your wall. And imagine that the crack was very small at that time, but because the water has gone inside, from where that water will emerge, because we have excavation at the base, and the water will be coming from the top, goes down, emerge from the base of your excavation. And that is the most severe and most affecting condition, which right now is the culprit of all major of the diaphragm wall collapse, either in Surat or maybe into many of the areas. And that's why this is very much important. And contractor will say, or diaphragm wall contractor, or even designer will say, how can I account for this? It's not possible. બહુ વરસાદ પડ્યો, પાણી આવ્યું, મારી wall ગઈ. That's fair. Nobody is responsible. Who is responsible? So, and if I feel that from the engineering point of view, you should be probably might have been thinking or foreseeing some situations based on the past area of your roads and area around. You might be knowing, અહીંયા પાણી ભરાય છે કે અહીંયા પાણી નથી ભરાતું, કે અહીંયાથી ડ્રેન જાય છે અહીંથી ડ્રેન નથી જતું. And that those are small observations, but that would save you. And had it been some drainage actually and probably carried out, or some housekeeping might have been done, probably this kind of a collapse might have been avoided. And that's what probably you should do that. This is one case which I probably would like to highlight, that we designed one diaphragm wall, or the T-shaped wall, close to railway. And this railway is Jaipur to Mumbai line, and that particular has let's say severe condition, because this line cannot be stopped for any reason, because it's a most busy line, and even we cannot say that the line has to stop. So all the careful, or all the design, or all the evaluations which you need to do, even for the railways which is at a high speed, I think 200 kilometer or 150 kilometer, whatever, but your system should not deflect, and anything happens into railway line, gone case, jail में डाल देंगे. So similar kind of a situation was there, but it was fantastic that has been done, and only 4.5 meter was the spacing from the diaphragm wall to the main line, first line, what you can see over here. That was and then construction sequence. Now let us come to one sequence. How will you do that? તમારા સાઇટ પર ડાયાફ્રામ વોલ ડિઝાઇન કરી છે, ડાયાફ્રામ વોલ થઈ ગઈ, હવે એન્કર કરવાના છે, એટલે શું કરશો? 3-4 મીટર એક્સકેવેશન કરશો. સો વી હેવ ડન ધેટ. લેટ્સ સે 5 મીટર એક્સકેવેશન કરી નાખ્યું, and in that 5 meter excavation there are some particular deflection which is going to happen at the top, which may be, which may not be, because if you are doing in dry season, probably the soil is not going to respond to you immediately. But in case of monsoon, nobody will dare to do that, right? Peak monsoon 5 meter excavation કરવાનું કહેશે તો કરશો નહીં કરો. He said that જવા દે, દિવાળી પર જોઈશું, right? So similar thing, let's say 4.5, then we install first anchor. I have never seen anyone who has been installing the anchor at the top 1 meter or 1.5 meter. If you do that, then and only then you will be able to control the top displacement. And otherwise, the moment you install your anchors at 4 meter, 3 meter or 3.5 meter, you will be never been able to control the deflection at the top at all. So be careful into that. Generally people do this. We'll go into the another sequence as well, but this is the first one. Let's say I have installed the first anchor and then stressed it. Then I install the second one, or the excavation has been done. So now from 5 meter, I move to the 8 meter excavation. And in that case also, the wall will deflect and you will see some crack on the top as well. And that shows that the diaphragm wall is responding to your excavation. And if that is the case, probably need to be careful. Now let's say second anchor has been installed and now the excavation has been done up to 12 meter. Now imagine the designer has given a design to install one particular anchor at this location as well. But builder बोलता है अभी छोड़ो ना, 12 तो पहुंच ही गए, नहीं करते हैं, एंकर नहीं डालना, खुद डालो, 2 दिन में कर देंगे. And then one anchor entire level has been skipped, right? What will happen? The wall and the ground is not going to respond to you immediately. It will take some time on readjustment of anchor forces, and some of the anchors will have a tremendous force, and once the wall has been already into the bed shape, your anchor has been already pushed out, which you will never be able to understand, because once stressed, you are not going to tap those anchors again at a higher elevation, which are at that 4 meter and 5 meter or 6 meters. So never take chance. If you really would like to take a chance, have a walkover survey around it and make sure that diaphragm wall has been not responding or has been not responded the way we have discussed. If you see any chance, then don't take chance, right? So that's the one particular major clause, and the diaphragm will not have a major or deflection or maximum deflection at the top if you are using the anchor walls. They are into the in-between portion, and the moment soil goes over here, probably the deflection or differential settlement is going to happen at the top. And this is very important, because people are trying to measure at the top, but you will not have a maximum deflection at the top. The maximum deflection will come at the base. And now imagine that if one anchor has been failed, what will happen to your panel? So એ તો ભગવાન ભરોસે જ, probably થઈ ગયું તો થઈ ગયું. આપણે probably I also believe from Bhavnagar, from the mention what you have done it. So આપણે કહેવત છે ને, મને સાહસ અને મૂર્ખામી વચ્ચે બહુ ભેદરેખા બહુ પાતળી હોય. So તમે ક્યારે ચાન્સ લ્યો છો ત્યારે સાહસ કરો છો કે મૂર્ખામી, એ તો તમને નેચર કહે જ. પાર પડી ગયું તો સાહસ કર્યું. People will have a tap, everything is okay. Builder will say, I will give you next job. અને જો ના પડ્યું તો so, okay, so this is probably many of you are also using plexus analysis. You can see this, the anchor stressing. I just would like to show you what is happening over here. No? And that is much more important. Now you have one second anchor has been installed. You already excavate to the full. If you don't install the next anchor and then try to further excavate it, probably nobody can save you in case of worst condition happen. No? So sometimes you probably, as I said, સાહસ કરો કે મૂર્ખામી કરો, મારી રિકમેન્ડેશન એક પણ નથી, નહીં સાહસ કરો ને મૂર્ખામી કરો. Right? So I say that you take an engineering decision based on your calculation, based on observations. Take a particular cautious call wherever you want to do it, right? And you see this entire thing is in an active wedge, and you see onto this on a passive side, that's a passive wedge. And mostly people forgot to take a global factor of safety, and that global factor of safety is overall health of your entire system. And if it is less than 1.2, you are running very close to your મૂર્ખામી વાળી લાઈન, કે કંઈ પણ એડિશનલ થયું, things will go. Here right now I am not talking about anything on reinforcement design of the diaphragm wall, because many of the Surat site builders probably may not give the job to me for designing, mostly because I specify many reinforcement, or the percentage of the reinforcement is always high from me, because I could consider so many things. But practically we do not have any failure cases where the things have been collapsed till date, and touch wood, we also do not see those things. But if you do some minimum checks, probably the failure chances would minimize, and everything goes on L1, because cost ઓછી કરવા માટે તમે કંઈ પણ કરશો, કોઈની પણ સાથે જશો, then you are taking a chance, and then you have to accept. Sometimes nature will support you, sometimes nature will teach you. So you need to be very careful for the system. So I will just go back. I will not show much more onto it. This is probably of not too much relevant over here. This is one monitoring right now is here. I just would like to come on this slide. We'll show you one small illustration from applications, and then I will hand over mic to Ravikiran. If anybody has a question, probably we can discuss. Just a moment. This is the wall, and probably now we think from the point of view of a designer, right? So how we need to analyze this. Many of people are doing this, that I will excavate and then I will do some slope and then I will do diaphragm from here. And many of you are doing this practice as well into that case. So let's say we are excavating this, the wall, or I would say the groundwater table is at 7 meters, and then we probably try to do this. This is actually let's say the same diaphragm wall designed for central vista right now into let's say the central vista which has been constructed in Delhi. So this is the same design. We'll see the construction sequence. Let's say we have excavated something from the wall, then we'll go further deeper, so that I will have an opportunity to install one particular anchor over here. But at the same time, the groundwater I'll keep on dewatering from inside, so that I will be able to install the anchors. And then probably sequence wise go install the first anchor, goes deeper, install the second anchor, goes further, install the third anchor, and again goes to deeper and install the final anchor. And then you see the final anchor has been placed exactly at the base of the excavations close to it, and then probably whatever excavation has to be done. Without this, no further excavation close to it. So then goes to the bottom slab, then let's say the top slab, and then goes on a backward, so that you will be having a basement which has been connected to it. Now let us try to analyze this and see how this entire sequence will behave. You see the predicted shape of a diaphragm wall when this has been excavated at, let's say, the maximum. You can see when the 3 anchor has been installed, but 1 anchor has been yet not installed, and you can see at the back of the wall, this has been the wall which, or the area where the displacement is being observed, and the maximum displacement would be at the location where your apex or your sections is there. This is very much important, because if it is at that level, whatever the lining which you are doing or whatever the grouting which you are doing, that will crack from the top, and then that would induce water or whatever the monsoon water or a storm which is coming. Maybe sometimes you have a farms also, so they will have a full of agriculture or cultivations at the back of it, and then you will have a plenty of water from those cracks. That would directly go behind of your wall, and that would create a problem for you. Now we can have plenty of results out of it. If someone says that I am more interested into bending moments, then the bending moments also can be seen as the anchors has been there. You can see if you eliminate the anchor, let's say I do not install the 4th anchor, though the designer has specified, but the moment would be practically operating is around 720 or something, and if you anchor and then pre-stresses, this will further push that wall, so your operating bending moment would be a bit reduced, and the designer might have designed correspond to those reduced bending moment. But if you eliminate one anchor, probably you are completely changing the shift from the reinforcement of structural forces which the designer might have assumed, and that would create a issue, because now your sections are running just to the capacity. If additional stresses or anything comes from the groundwater, and the crack will occur from this level, and then the diaphragm wall will further collapse like this triangle. So that way it is more important. I will probably stop it over here. If you have any questions, probably we can discuss, and that's it. Thank you.
તે જે પ્લોટમાં આપણે ખોદવાનું છે તેમાં કરવામાં આવે છે અને એડજોઇનિંગ સ્ટ્રક્ચર્સ કે જ્યાં તમારે એન્કર્સ જવાના છે તેનું કોઈ ઇન્વેસ્ટિગેશન કરવામાં આવે તો એનો કેટલો ઇમ્પોર્ટન્ટ રોલ રહેશે એની અંદર અને એની કેટલી અગત્યતા.
Particularly, let's say from the engineering point of view, you may not have that opportunity and liberty to get all the soil data around your site. But still, the designer will assume something based on the diaphragm wall or whatever the soil investigation data which you offer to them. And in that case, there is always a risk. And that is why, instead of going purely on soil data which has been given as an assumption, when you try to install anchors, you will have a much more and better information of what are the strata and what are the, let's say, the performance of your bore for the anchor installation. And that is more important. Design issuance is one particular aspect which has been started. Construction, if you have something bad experience on the anchor installation, you augment your design assumption, increase number of anchors, reduce the anchor force, and accordingly you need to augment it. It's not like that whatever the design has been given and that particular is there. But the soil data is very much important. Sometimes it may happen that your subsoil conditions, or you have a thin layers of your sand or a fine sand which is a water bearing, and that particular creates the issue.
But I think there is, in normally what we see, there is a no direct communications between the designer, the contractor, and the site engineer.
So that's a serious complaint from our renowned structure engineer, that from builder, from the engineers and the designer, there is no coherent communication, so that this particular will be always successful. So wherever the miscommunication happens or disconnect would occur, there are always chances of having let's say, I would say failure is a bad word, but incident probably maybe the better word to describe. I think for few of our case also, same thing. I still remember one of the case in Adajan where we went for this pile draft or something. The adjacent property buildings have experienced some cracks and all these things, and that's why we stopped further excavation. I think many of the cases it has happened. One of the site in Rajans, where because when we submit a design, we keep on coming on visiting those sites. Even though customer pays or do not pay, it doesn't matter. But probably we do that way whatever we can do for that site. So we observe that the sand boil, what particular I have shown to you, and we immediately stop them to construct a third basement on one of the sites. On the other two sites, probably we allowed them based on our experience. But on one side, we said that don't excavate on this side further, or instead you excavate something from here and locally dump it over there for next season. Once you have a 2 towers or something has been there into this phase, after Diwali or after monsoon, you can again try and come over there so that the water pressure has been reduced. But that kind of at least communication should occur, that even builder also should accommodate such kind of let's say the adjustment if required to I think avoid such kind of incident. Nobody likes such incident, right? So it's fine. Probably, let's say if I say that I have a building basement excavation, if excavation basement depth is 7-8 meters, probably the utility behind or a house behind may not get affected. Even if it would be a permissible deflection with the base, it's the behind the wall, what are the facilities are there, that should decide the permissible deflection. So let's say I have a 13-meter excavation depth. If I say that I have a 130 mm permissible means code will admit 130 mm, you will save 130 mm, but your building is at the back is going to crack at 130 mm as well. So that guy has nothing to do what code has written, but the bungalow, or I would say the one unit which has been there at the back, if you allow 130 mm, it's going to crack. So it's not that the wall, the excavation depth, it's the utility or surrounding facilities need to be designed appropriately. If the same thing has to be designed by myself, I will give one particular anchor at the top so that the top deflection I will govern or restrict. I will not allow that top wall to be deflect to 130 mm. At the deeper level, if 25-30 mm goes, it's fine. But then it's because on utility, I have designed accordingly. Permissible could be anything, maybe let's say 10% or 0.6% of your wall excavation depth, but those are not for the urban excavations. Those are for normally cantilever or retaining wall kind of a thing. So always do not look towards the let's say the code, you know, दिखाओ पे मत जाओ, code पे मत जाओ, खुद की अकल लगाओ, something like that.
Sir, whenever we distress the anchors, what would be its influence on the structures behind them or the new construction?
It will going to respond definitely, because sometimes, as I said, there are some volume loss has been there during your anchor construction. So all the volume loss has been never been occupied with the grout which you try to push. So that's going to happen, but you can imagine that you have already stressed 30 ton, 40 ton, or even 60 ton sometimes into the case. Then you suddenly cut it. Definitely, the wall and the soil, which are also giving the reaction, is going to relax, and that relaxation may have some issues with the small buildings, but majorly, in case there is no volume loss or there is no volume change, probably there is no issue.
Okay, what about the new construction that has been carried out inside the basement?
I think if you have already braced it at at the slab level, probably that's not a big deal into that. Your diaphragm wall has been de-stressed because the moment you have a raft at the base, and then when you connect with the raft, that surcharge would also give the sufficient passive resistance and a support system so that your diaphragm wall can take it. But definitely the inside the wall, probably there are less chances of having a structural influence of the de-stressing the wall. But definitely don't assume that wall is not going to have a plus minus. You just already praised that wall, you remove and cut that thing, and then that wall is going to respond to you. And that response would be generally around 8-10 mm or 12 mm. So if you have a tight, let's say combination or tight particular contact, then you can see that there are some locations where some crack has been there at the slab level. But I do not see that it would respond or restrike more than 10-20 mm onto that any case. Beyond that, it's not likely to respond.
સર અત્યાર સુધી જે સાંભળ્યું એનો તો એવું લાગે છે કે વોટર ઇઝ અ વિલન ફોર ડાયાફ્રામ વોલ. મારો એક નાનો ક્વેશ્ચન એવો છે કે જનરલી સુરતમાં પણ અમે જે જોયું કે જેટલી ડી વોલ પડી છે અત્યારે પાણીને લઈને તો આપનું શું સજેશન છે કે એક્સકેવેશન મોન્સૂનમાં કરવું જ નહીં જોઈએ?
I come from the EPC construction background, so we never see the clock with reference to monsoon. So I probably have a different viewpoint that we should not do excavation in monsoon. We may do, provided that we are prepared for it and we have designed for it. If you have taken so many of caveats in design that the diaphragm wall groundwater table is at 10 meter, 12 meter, and there are no pore water pressure, there are no calculations, and so many things, then probably you are in a much more riskier position. If you do excavation in monsoon, then you will be able to do that. But it's not like that people do not do monsoon. In EPC, people will never wait for monsoon. Even if it is the peak monsoon, the construction goes on. So that's fine. First sentence which you have said that water is villain, I would say that don't fight with water, or don't try to probably control the water. Water is not a villain. Probably it is there, it was there, it is there, and it will going to happen, right? But thing is that facilitate it. Don't try to fight and challenge it. People actually miss this thing. If you try to challenge the water, probably that fight you will never able to win. Definitely in turn, for after 15 days, 20 days, 1 month, one instance will come, everything will go into flash. And that's because you have misjudged the properties. I have not shown something over here, but uplift pressure is also a culprit. Probably maybe in some next session something will have those things also. But don't underestimate, I would say, because as I said, I have been coming from EPC background. You can imagine that 3.5 meter diameter pipeline, 3.5 meter diameter pipeline, steel pipeline, entirely buried, which has been came up in a flash within 1 hour, because the one particular break has happened into some adjacent canal or some water line. All the water came to those area, and then that buried pipeline came up. And now you imagine how much the force it can generate. You will not be able to lift all these things with a bare crane or something, but water can do that. So that fight you will never going to win. So don't fight it, facilitate it. Where water up, મને દેશી ભાષામાં કહે તો રસ્તો કરી આપો. Water should not guide you, you should guide water. That please come out from this location, don't come from this location. So that's it, simple.
Thank you very much, Dr. Jaybai.
Removing the water, and so what is your view on that? Any situations they just remove the water?
Okay, so one important point what let's say Hiren Bhai has highlighted is how you dewater, right? Say somebody says that in many of the areas of Vesu, I don't know, where you have a canals and your groundwater is at 3 meter, you have interbedded layers of sand, and then you think that I have constructed the diaphragm wall and now I am eligible to dewater from inside from the sump, no, small sump. And what probably you are doing is you are allowing your water to come inside your pit and then you handle it, right? That's a wrong way to handle it. Because you should not allow a single water drop to come inside your pit. You should always try to dewater from outside if the water table is high, and that would always increase your factor of safety. So believe me, one particular important, let's say, if your water table is high, never try to go dewater from inside. Install some deep wells outside and continue dewatering from deep wells. That would save thousands and crores of yours. Such kind of incident it will happen, because that's the most, let's say, tragic situation if you have it. Don't try to go always from the sump pumping. That always creates like a hydraulic difference. If you don't want to do that, go install few deep wells. 5 HP, 2 HP pumps, you install it. How much it costs? Nothing, peanuts. But still you will be able to handle everything inside the pit in a dry condition, as well as you can do PCC and a better condition into very capacity also. Imagine such kind of uplift pressure has been there, and now we are putting a big raft on the top of it. Whether that bearing capacity will be available, I don't think so.
To appreciate the presentation was very easy to understand, and the concepts explained through live projects and the behavior explained through software analysis. It was really very nice and easy to understand. Thank you very much once again, Jay Bhai. We appreciate with big rounds of applause. Thank you very much. Now I would like to invite my young dynamic friend architect Jason Shah to introduce our today's speaker, engineer Ravikiran Vaidya.
Esteemed colleagues and members of Icea, it is a privilege to introduce a visionary who didn't just adopt deep foundation testing in India, he created the industry. Please welcome Engineer Ravikiran Vaidya, Principal Engineer of Geodynamics and alumnus of MS University of Baroda. Engineer Vaidya brought techniques like high-strain dynamic testing, EIT, and sonic lodging into the mainstream. Today, these testing protocols form the backbone of safety for India's most critical infrastructure, from bullet trains and metros to major highways and marine structures. Together with Dr. Jaykumar Shukla, he indigenized bi-directional load testing for high-capacity piles, pushing the boundaries of what our nation's engineering can achieve locally. Recognized with the prestigious Dinesh Mohan Award and the IGS Leadership Award, he serves as the chairman of the IGS Baroda chapter and represents Pile Dynamics USA to speak on diaphragm walls and deep foundation, design, construction, and best practices. Please join me in welcoming a true pioneer of geotechnical engineering, Engineer Ravikiran Vaidya.
Thanks to ICEA and Naren, my classmate. Wonderful to see you all here. I mean, when I came here, Naren has always been telling me that we are about 1,000 members of a group of architects and engineers both. I mean, that's very, very unusual throughout the country. And if you can replicate this model, then there will be a voice of engineers to be heard right up to the parliament, which is what we are lacking today actually. So thanks once again for inviting me and being a part of, it's a privilege to be amongst you all, some friends, some senior colleagues, everybody here. Now, I think there was one question on, do we not excavate during monsoons? So I think India is one country which has a very defined monsoon. And there are so many countries. You go to Singapore, you go to Malaysia, you go to parts of US, and it rains throughout the year. So what do you do then? So I think there is no such thing as you don't excavate during monsoon. As Jaykumar rightly pointed out, you just design it to take care of these things. And we all know water is a friend, water is also an enemy at times, and depends on how you treat it and how you look at it. So now I think having designed everything, the question is I designed everything, but I mean we still see collapses, we still see failures, and it's very easy to say, like हर जाके एक diaphragm wall का चक्कर मारो, what to do, you don't, we are really short of good people, so we really don't know what to see, where to see, how much to see. So there is always a challenge between what to do. So, and especially, when we see a collapse, बाजू वाला सोचता है यार वो मंगनू तेरा हुआ मेरा क्या होगा, like, so he's always worried कि बाजू वाला ये तो गिर गया अभी मेरे तक पहुंचेगा नहीं पहुंचेगा. So we end up doing all these things so often. These are some collapses which you have seen. Sometimes we have actually gone and tested and we have seen that they were failures and we have alerted them that yes, be aware something is happening. So this was a very recent case about few weeks ago, collapse just adjoining a metro line, and then the metro authorities called up saying that there is a collapse. What do we do now? Does our peer or do our peers get affected? So again, you put some systems in place, you try to monitor them and just see that things are not as bad, take some protection, get a designer to redesign things. So we'll see there are secant piles, there are contiguous piles. So there are two things in addition to construction and design, or design and construction, you want some testing because you want to know what happens during construction, what happens after construction, and what happens after excavation until the time you're above ground. So let's see. I am not going because we are all hungry. I'm sure it's 8:30 and so we will try to keep it short. I'll try to go through the bird's eye view of each method rather than going into the details of it. And maybe there is some session because each method is quite evolved and is going to take a lot of time. But there are some things which we thought we'll introduce is to shape and Gordhan, integrity testing of wall panels, thermal profiling. I think we'll skip that for today. Dynamic testing, bidirectional, not necessarily in that sequence, but we'll see a lot of these things kind of a bird's eye view. So one thing what we have seen in metro and they specify is they want Gordhan. So Gordhan is basically you want to know the verticality of the wall when you are drilling it. So if you want to know, so when you are drilling it, the first challenge is whether the equipment can drill a wall vertically. So there are now the new equipments, they give you the inclination of the wall as you drill. But some of the older ones do not give that. And even with the new ones, you are still dependent on the operator to tell you whether it's truly vertical or inclined. So the Gordhan is basically kind of a tool. It's right here. So it tells you as it goes down, there is a probe, and the probe measures the time of travel. So you know the distance between the walls, and then from there you get, you know the time of travel, it measures the time of travel, it calibrates the wave speeds, the velocity, and velocity upon time is distance. So you get the profile or the verticality of the wall based on the distance from where at the top. Now so Gordhan is something which has been used for long. It's a Japanese tool. It gives you the verticality of the wall, but it doesn't give you the profile of the wall. So now the challenge is to know the speed. It's just like ultrasonic. Speed is equal to distance upon time. So if I want to know the distance, I must know the speed. Now when you put the probe inside, your sand content keeps changing as you go down. And that means before you do a Gordhan, you must calibrate it each time with respect to that particular fluid, which is depending on bentonite, depending on polymer, depending on sand content. Now you have only one probe there. So is there a better way? Now you can see here, this is your profile. So this is what you get from Gordhan, and this is what you get verticality. So this is what you get. And you can now have a fair idea of what my actual cross section of the wall is at that particular sector and output. Because the Gordhan is a kind of an older technology. When you put the probes inside and you pull it, it comes out with a script chart recorder, and you really cannot do anything after that. So you don't get raw data files, you can't play with the speeds, you can't get back and correct those things if you really find something is wrong with the output. So is there a better way of doing it? And then what we have is shape. So with shape, it's a shaft area profile evaluator, useful for both pile foundations and for D-walls now. So they have come up with this D-wall. We have done trials. It's almost done now. So what we have again is multiple sets of ultrasonic sensors and a transmitter and receiver as well. So we'll see that quickly. I'm not going to go through this. So typically built-in calibration pulse to adjust for variations in wave speed. That's something which is very important, and about 1 scan per second. So yeah, so this is a Kelly bar. You can connect it with a to the equipment itself, or there is a kind of a pulley system. These are our calibration sensors. This is a pressure sensor, so you get the depth as you go down, so you can actually measure the depth, and ultrasonic sensors, and a transmitter and a receiver. So you can see here as it goes down, it senses, and because there is a calibration sensor at the top, as it goes down it keeps on calibrating the speed, so it keeps on correcting itself. In addition to that, you can transfer it to a laptop, go back, recheck your speed and correct it, but the output is both. You want an instantaneous output. The moment you put the equipment inside, you get one output, or you could pull it outside and you get another output. So you now get the verticality of the wall. I'll just show you something more. So you can see here, measure radius is equal to wave speed upon time, or distance is equal to speed upon time, and this is what you get, and this is what you get if you are uniform. So the number of cross sections you do, and you get the verticality and the profile both at that cross section. So this was a trial which was done, and this was a specifically cast kind of device, and this was the output. And we have done it for bullet train, we have done it at locations in Surat, and this is what you get is the eccentricity of the pile or the wall as you go down. So you know where the eccentricity is. And this is what we did in Surat, and then for a couple of other projects. So you can see here. Now the challenge is, the equipment width itself is like about 300 mm, and we all know when you have a 600 mm wall, your equipment has to be reasonably near the center. If you are touching the walls, you are not really measuring the speeds. So then of course it's not vertical if you are touching the walls. So but you got to be careful when you are collecting the data. You must have a fair idea, because your sand is more at the bottom, more cleaner water at the top. So again you got to keep on adjusting your speeds before you come. I mean, people have been doing Gordhan for ages, so it's not something which is new. But nobody, I think whatever data we collected in the past few years, and we found that most of them were just doing for the heck of it, and nobody even knew that you got to calibrate it each time, first time, get it back, see your profiles, come back and redo it again before you do it, and that's a challenge because you don't have the data files. So that's where the shape is probably a better tool these days to get the profile of the wall. And you can see here, this was the profile that we got when we did it. So you can get the profile and the inclination both. Now you got the profile of a D wall, and then you cast it. Now when you cast it, we don't know how good the concrete was, whether it was continuous, whether there were cold joints. We all know with the urban areas, you do the drilling in the daytime, but you do concreting at night, and you really don't know whether there was a collapse, whether that was really a good quality wall or a bad quality wall. So what we do is, integrated testing has its limitations, because what happens is when you hit at the top in a foundation, it's a one-dimensional member. So the wave goes down, hits the bottom and comes back. L by C time to go down, L by C time to come up, so 2L by C time. But the area is defined. So you can be much more accurate with pi. Now the moment you apply it for a D wall, you hit at one point on the table and you see the pulse at the other point. So that means what you see, what you impact here, your return is not necessarily where you actually hit or where the probe is, and that makes it much more uncertain than what you would do with a pi. So what do I do then? Well, the only way I can do is probably I take bigger and bigger hammers and then send a shock wave. So even if some of it goes to this side, at least I get some of it back in the return, and that the wave which comes the first is the one which is caught the first. So there are multiple waves. The equipment or the science really doesn't understand, because you send a shock wave, will all feel here everywhere. But the wave which comes back first is the one which is the shortest wave or the quickest one. And that's where we try to base it upon, and we try to do this integrity using a multiple set of hammers and try to see if there is a similarity between the graphs. I mean, that's all I can do. So the method is truly applicable for pile foundations, but with trial and error you try to, because that's the easiest way to do, you don't need any advanced preparation, you don't need advanced kind of installations or any installations before you do it. So this is what you try to do, and I'm not again going into the principal part of it. I think we are short of time. But what we get is a velocity versus time curve, and now you can see here this was a good wall panel, but if you see here this was something which was shorter in depth, or maybe there were some collapses at this point. So we still get a reasonable data. I mean, we don't claim we are 100%. I mean, in pile foundations we would have done studies over 25 years, and we have tried to say what is the percentage accuracy. We were about 90% in most of the cases. So again, with integrated testing it's nothing like 100%, but if you do it truly correctly you're 90% right, and with diaphragm walls I think the percentage goes down a little bit more, but you still get a fair estimate of, a reasonable estimate of what your wall would be like. Again, if you have a wall which is 5 meters in depth or 5 meters in width, I would not do it at one location, and people make a blunder. I would test it at every 500 mm to be sure that I have enough data set, because you might have a wall which is okay up to a certain depth in this location, but when you go to this point there was a collapse localized, and say for example you are 20 meters, so this is 20 meters but this is 18 meters, and you might still have a partial collapse. So I would rather test every location and come up with a overall conclusion. So that's what we do, and these were shoring piles, and this was actually excavated and we found this. So is there a better way? So you got a cardiogram, I got a cardiogram, so the integrated test is like a cardiogram. Is there a better way to get a kind of X-ray of a wall? Can I get a picture of what my wall looks like? And then what we do is cross-wall sonic logging, which is so common, and this is something which we do so often, is we put pipes inside the wall panel at equal depths, at equidistant points, and then you send a transmitter and a receiver right down to the bottom and then scan between those two pipes. So now you get a picture between those two pipes, or what we call is a waterfall diagram. Okay, so let's see this. So this is a transmitter, this is a receiver, this is a cross-wall analyzer, and then you put 38 mm or 50 mm mild steel pipes. Don't put PVC pipes. Again, PVC pipes, what happens is after the concreting, because of the heat of hydrations, the pipes tend to warp, and there is a kind of a loss of bond between pipes and concrete. So we prefer MS pipes. One pipe for 300 mm diameter of pile, but for a diaphragm wall you could have it at 1.5 meter center to center, or you could have it in a zigzag form. Our next slide will show that. And MS pipe should be rough, not coated, nor smoothened, nor oiled to keep them smooth, so don't do that. And extend them to the bottom and pour water immediately after concreting, or before concreting. Check that the pipes are open and they are not blocked. So these are typical pipe configurations for a diaphragm wall. You can see here, 3 on this side, 3 on the other side, just so that your diagonal is not more than 1.5 meter. For pile foundations I can scan even more than 2 meters, but with diaphragm walls over time what we have learnt is this is 1.5 meter is preferred. If you have a pile foundation, it's something like this. Now what we recommend is something like this, but when we go to site we see something like this. A lot of times the pipes are not put properly, or the number of pipes are too less, and now what happens? You just miss out everything on this zone. Okay, so it's shifted, or I don't know how did they do this, but this was some real study. Or if you put less pipes in one quadrant, then you are missing something here. So this is what you do. You put the probes, you pull them at a constant rate, and then you get a waterfall diagram. So that's kind of an X-ray of a pile. Now there is no doubt, there is no ambiguity. I can see something. If I see a small defect, that's a delayed first arrival time. So this is your first arrival time, and there is an energy or the voltage which goes from a transmitter to a receiver. So if there is honeycomb or there is loss of concrete, you see that the voltage has dropped because the concrete is lost, and you see the wave speed. So you get a feel of the concrete quality. Again, speed is equal to distance upon time. So you get the speed. Remember what we saw in integrity was stress wave speed, and what we see here is ultrasonic speeds. So again, stress wave speeds are different from ultrasonic speeds, and you might have a kind of fair correlation between them, but they are not the same. So these are some standard guidelines for acceptance and rejection of the wall panels. But again, in diaphragm walls, you got to look piece by piece. Yesterday in Delhi, and the question was fine, you told me there is a defect, but what do I do now? मैं करूँ क्या? आपने तो बता दिया. And I mean, with the pile foundation, the answers are much more easier. I can core it, I can drill, I can check, I can grout, or in some cases I can reject. What do I do with wall panels? Well, in some cases, I remember the classic case was one of the metro projects in Chennai, and we were telling them kindly monitor them to start with, because I would say these are like early warning systems. Doing your first 5 wall panels, I would rather do sonic logging and be sure my workmanship is okay, my equipment is okay, everything is okay, and then I can reduce that testing. But you do everything and then you call us after the diaphragm wall is over, excavation के पहले एक बार देखते हैं क्या हुआ, what do I do? Everything is constructed. So I would rather do it for the first 5 panels at a job site and be sure that my workman or my contractor is doing it nicely, or my design is as per my construction, everything. So there are choices. You could drill horizontally sometimes, you could drill vertically sometimes, or you could grout those pockets and then put some additional veiler beams, put some additional anchors or whatever, just to be sure that there are no unforeseen situations. So now what happens with PVC pipes, and why we say, you can see here there's a complete loss of bond. So this is not a bad pile. In fact, you can't have concrete. Where did the concrete go? Now you still have enough concrete which went inside, but this was missing signals because of poor pipes. And this is what we see when we see defects. We have code extensively at times to validate, and again, I think success rate is actually more than 95%. So that's what you can get from sonic logging. And the precise location of defect as well. So you know up to what point to core. And this was the data we got about 2 days ago, and you can see here these were problems. So this is something they can still manage, and they're still wondering what do I do, because my excavation is probably only up to 14 meters and my wall is about 17 meters. So that's a challenge which we are still sorting out. And this was a case where again poor pipe quality caused poor signals. So I think you got an overview of sonic logging and what it can do. We could also do the integrity of wall panels by temperature measurements. I have not included it here, but I can measure temperature in a wall panel, and the heat of hydration is constant over the first 72 hours. So you expect from 70 degree temperature within concrete or 75 degree temperature within concrete, it coming down to 40 degrees over 72 hours. But if there was a loose pocket, you will see the temperature dropping suddenly at that point, typically what we do for mass concrete. And that means the point at which your temperature has dropped suddenly is the point where there is a possible defect. And that's what thermal integrity is. Again, due to time, I don't go into it, but now these days we see designs, I think Jay and some of you all design barrettes, load bearing barrettes. So you have vertical loads on the wall panels, and that means now you are not only worried about your integrity of the barrette, but you want to be sure that the barrette can take the load of it. So what we do is dynamic testing for board piles or driven piles, which is so common. We end up doing it for barrettes or D-walls, as long as I can extend the wall and put my sensors. Now again, the dynamic testing is a complex subject which will take maybe a few hours to explain, but simplistically speaking, if I give a force at the top and that force goes to the bottom, for a fixed end condition, for a rigid body, action is equal to reaction. For an elastic body, if I give a force F, if it was a fixed end condition with no soil, double the reaction, just like a bouncing ball, boom. Okay, so if I measure the force at the top and if I measure my return force, that would be my capacity. Now we are neither in a rigid body or a fixed end kind of condition. A free end is the other way around. I give a force F, 0 at the bottom, no reaction, right? So we are somewhere in between for loaded panels or loaded piles, and that means whatever is my return force is basically my capacity. Of course, I need to add a model for soils. When we talk of modeling of soils, we talk of damping, which is the coefficient of friction in this direction. As the panel or the wall goes down, you have radial damping, and then you have a return reaction, then you have a damping elasticity at the bottom, you have a plug at the bottom. So all those things I would need to model before I come up with an answer, but that's all possible. And so what we do is we use strain gauges and accelerometers to measure forces and displacements, and then use a basic equation, but later on model that equation and come up with a final answer. So typically you have a hammer which generates a force, and then you measure those from strains and accelerations and come up with an answer. So this was a wall panel which was cast for the purpose of testing, and you can see here we had this hammer so as to ensure a concentric fall. We had a guided arrangement and a hammer which was exactly the size of the barrette falling onto this wall panel, and we could now measure the capacity. So this was about 39 meters wall panel, concrete grade M40, panel size is 3 meters by 1.1 meter. We had a 19-ton hammer because the test load was 1000 tons, and we calculated what was the force required by a simulation to move the panel and to get the return force, and we could test it, and we reached something like 1700 tons, and this was our friction distribution broadly, and these were our data. So it's possible to test wall panels, vertically loaded wall panels as well with the impact, right? So that was something. And then is there another way of testing wall panels statically? So we did a dynamic load test, so that's kind of a force. But is there a way to do a static load test on wall panels? Now doing static load test on wall panels, particularly like 3 meter or 5 meter wall panel, and if you look at the code, you want a girder which is like 3D of the size. So let's say 5 meter wall panel, that means you need a girder which is more than 15 meters. And the massive size of the girder and cartilage means that you really cannot do a static load test on a wall panel most of the times. And then is there another way of testing a wall panel statically? So what we do is we do a bidirectional static load test rather than a conventional static load test. So instead of putting a cartilage at the top, let's say for example my load was 2000 tons. So that means I put a reaction system of 25% extra, which is 2500 tons. I put my hydraulic jacks here and then apply the load so that 2000 tons goes down and 2000 tons goes up, but it doesn't topple because you have a reaction which is 25% extra. And that means now I can apply the load from the top. And where this load contribution comes from friction and from end bearing. Now if I can calculate this friction from soil investigation and an end bearing, and I can make a reasonable assessment. I want a borehole data which is close to this, and what you mentioned as your question. I would ideally want a borehole data from the adjacent plot, and we have seen when we are drilling anchors, we end up with something which is very unusual. And one thing which we always tell our operators is when you are drilling, get back to me with what samples you found, because we want to be sure is what we saw in the borehole data is what is there available at site. So if I can know this force and end bearing in advance, friction from computation, which of course has to be validated, then I can split this F in such a way that my friction above this point, I put my jacks at this point, and now my friction above this point is equal to my friction plus end bearing below this point. So instead of putting the jacks here, I am putting them at an intermediate point such that my friction above this is equal to friction plus end bearing below this. And now I don't need any cartilage, I don't need reaction systems, I don't need girders, and I can simply put jacks at an intermediate point and do a load test. Again, this is not something which is new. This has been in existence since about 25-30 years. There was a patent to it, and 2016 the patent got over. So the ASTM was formed, and 2018 the IRC subcommittee was formed, and I was invited to that, came up with these guidelines. And what is known as OCEL, previously known as OCEL, now is known as bidirectional static load testing. So me and Jaykumar got together, we practically indigenized everything, and now we compete with all the foreign players. And I take pride in saying that some of the jobs we did, 120-meter length of pile, one of the longest drilled shaft in the world, 10,000 tons. We got the job against international competition and actually successfully completed it. But you can use it for D-walls as well. So this is what we do. We put instrumentation. So when you apply the 4 or load, you not only measure the load transfer through the jack, but you also measure the unit friction from strain gauges. So for example, you apply 1000 tons, here it is 800 tons, 600 tons, so I know it's 800 tons here. So 200 tons, so I get my unit friction. So from a design point of view, I am not only interested in whether load liya ki nahi, but kitna load kahan pe gaya. That is also important to validate the design. Okay, so again, because of time, we don't go through this, but these were our jacks. So for example, this was Mumbai Trans-Harbour Link. We had 5 jacks of 900 tons. It was a test of 6,250 tons, and then we put 5 jacks of 900 tons, so 4,500 tons, and then we had a top plate, a bottom plate for a pile foundation. But let's quickly go. These were our funnels through which a tremie can go, and these were our hose pipes which came from the bottom to top. This was quickly our arrangement. So the rebars are cut, so you can see that this segment goes up, this goes down, so there is no connection between the top and bottom segment. But if I go to a D wall, I can design it a different way. So we did the sonic logging as well, and let's come to a D wall. Yeah, you can see here. So now this was a D wall for 1000 tons, 600 in width, and we put 2 jacks of 500 tons, and these are my cutouts for tremie, and these rods are cut after the assembly is lowered into the cage of the pile. So this is welded to the cage, something like this. You can see here, this is welded to the cage. So top cage, bottom cage, assembly inserted in between, and now you do your concreting and you can apply the load. So you can do static load testing with a bidirectional load test for a D wall. You can do a dynamic load test from a D wall in certain cases. So now you got the profile of the wall before concreting, you got the integrity of the wall after concreting, you want to know the load taken by the wall, you got it from a load test, and now let's go further. सब कुछ कर लिया, फिर भी बाजू में पानी आ गया, excavation हो गया, कुछ हो गया, I don't have control over so many things. So can I still have a kind of an early warning system? So what we have is inclinometers. So inclinometers will tell you about the drift. So it will tell you about the drift as you keep on excavating the wall. So you know what Jaykumar showed is, as you excavate, there is a kind of a movement. Can I monitor that movement? You can. And the simplest way is inclinometer. So there are 3 types of inclinometers again. You have a torpedo type where you put the probe inside, and at every location there is a slotted pipe. So when you do your D wall, you put a PVC pipe in the D wall at a point where you want to monitor. That PVC pipe is typically a slotted pipe, and then you put your inclinometer probe and you get your soundings at every depth. So your first sounding is your 0 reading, okay, and then every time you take the readings, you get a new set of readings which is compared with that 0 readings, and simplistically speaking, if there is any movement, that's like sine theta, and from theta you can get the inclination and get the movement of the wall. So something, if you want to do periodic monitoring, you have a torpedo type. So every time you come weekly once, take the soundings and go back and present something. Now if you are really worried, I want a continuous monitoring, then you have in place inclinometer. So one unit connected to the other, right through the depth, connected to a node or a data logger, goes to the cloud, and you get on your mobile or on your PC in real time. So you can keep on getting those readings. We can set the frequencies to anything from 1 minute to a few hours as required, and you can keep on getting the movement of the wall as and when you keep on doing your excavation. So that's something which we proposed to the metro as well. We said, you already have a collapse, and now you're worried whether your collapse keeps on increasing, the soil keeps on falling, and what do I do now? So the best way is put an inclinometer system or a series of inclinometers and keep on monitoring till the time you take some rearguard action. Or what we call is shape arrays. So this requires a slotted pipe This one doesn't require a slotted pipe. It can go in any angle, in any direction, and you don't need any slotted pipe anymore. Obviously, each one has a commercial angle to it, and as you go along the line, the cost keeps on increasing, because this is something you're monitoring once in a week or twice a week. This is something which is continuous, and this is something which is more flexible, so that's a little bit more expensive than this one. So, but things are possible. The idea here is to show that everything is possible to monitor and get a real time alert before disaster strikes. And this is what you can see. We have installed some sonic pipes, and we have got some now real time monitoring on the screen, and you can see here I can get the deflection pattern as the wall deflects as you keep on doing your excavation. And if you have certain limits, you could set those limits, you could have alerts, you could have everything on your screen or on your mobile. Now, so you monitored the D wall. Now when you do your D walls, you have a variety of situations. You have veiler beam and anchors. Anchors, again, monitoring anchors, I am not going to come here, but you have multiple jacks to keep on checking the load, so that's something which you do often. You might have struts, right, and you have designed your struts to take a certain force. Now you still want to know what is the force inside that strut, because you use your turnbuckle and keep on applying and you tighten it, and now as you keep on excavating, your wall tends to buckle, and then that increases the force on the struts. So what we do is we just mount some sensors on the struts and calculate the actual force that's coming on the strut as you keep on excavating. And now you can know that yes, this is the force for which I designed, and this is the force which I am measuring. So you have a combination of an inclinometer system which tells you about deflections, and you have forces in the struts if you are using struts to get you what actually is the limiting values. So this was something with vibrating wire strain gauges and surface mounted strain gauges, which is possible. So again, I don't go into the details of it, but you can have a trend, you can have early warnings, you can have design verification, a lot of these things can be done. So you can have a continuous monitoring with struts and forces as well. And again, you have a variety of systems in place. You might have a diaphragm wall, you might have a contiguous pipe, you might have a secant wall panel. So depending on what kind of a deep excavation support system you have, probably you can design a testing mechanism, a monitoring mechanism, and there is no such thing as a straight one-for-one answer that one works in this case, may not work in the other case, but put together everything, we can still monitor a lot of times. And some of these, typically when you go for multi-level basements, I think these are things which are there in the market. Some of them are used, some of them are extensively used, and some of them are likely to be extensively used. So my idea here was to give you a kind of an overview of what are things which are possible and what are things that can be done. So there is nothing like, don't excavate during monsoon or don't excavate during this season. You could monitor everything, you could design for everything, and in most cases, unless of course a natural calamity strikes and you haven't configured that, I mean if you have configured that, even that's possible, but if you haven't configured that, you should still have a safe foundation or a safe structure at the end of the day. Thank you very much, and thank you Naren, and thank you everybody.
Suggest minimum instrumentations for normal building diaphragm wall size. Minimum.
The minimum I would say is at least do some sonic logging to start with. I mean that's the bare minimum, because sonic logging can be done 3 days after concreting or 7 days after concreting. So early, check on the project, on the quality of work, on the parameters. Say for example, you might have concreting issues. You don't even know that there is an issue. So if you have something which you get in the first 7 days time, you can correct that situation. So you are not like doing a post-mortem. Otherwise, what happens is a post-mortem. So I would say the minimum is some sonic logging should give you a good feel of everything.
Thank you very much, Ravikiran ji, for the wonderful presentation on instrumentation and technologies for better quality control, which will definitely help to minimize the gap between design and execution. So once again, thank you very much, and we must appreciate with a big round of applause. Thank you very much. Friends, we would like to appreciate and acknowledge the presence of dealers from Kamdhenu Steel, Mr. Sunil Bhai from Paras Steel Agency, Mr. Niket Bhai from JK Steel, and Mr. Harin Bhai from Vaishnav Infrastructure. So we appreciate your presence. Thank you once again. Now I would like to invite all the office bearers of Icea Surat and the team of Kamdhenu Steel to offer memento to our today's speaker, Dr. Jaykumar Shukla. Please come on the stage. Seminar you can collect in the next seminar. Now I would like to invite Engineer Jatin Bhai Patel, Honorary Secretary Icea Surat, for secretarial announcement.
15/9/2024 રોજ તમને બધાને ખબર જ છે 20ના રોજ એન્જિનિયર્સ ડેનું ભવ્ય સેલિબ્રેશનનો પ્રોગ્રામ રાખવામાં આવ્યો છે. એ દિવસે બધા મેમ્બર્સો હાજર રહે એવી અપેક્ષા રાખીએ. બીજા 2-3 પ્રોગ્રામ પણ પાઇપલાઇનમાં છે અને એનું જેવું નક્કી થશે તેની ડેટ આઈસીએના ગ્રુપ પર શેર કરવામાં આવશે.
It's my pleasure and privilege to propose the vote of thanks at today's technical seminar organized by Icea. Today's seminar on diaphragm walls and deep foundation design, construction and best practice is a highly relevant and technically important topic for all professionals associated with civil engineering and construction. I am sure today's session will enhance our knowledge and provide valuable practical insight that we can apply in our professional life. At the outset, I would like to express my sincere gratitude to our esteemed speaker Dr. Jaykumar Shukla and Engineer Ravikiran Vaidya for his sharing their valuable knowledge, experience and expertise with us. Your time and effort in delivering such an informative technical session are duly appreciated. Thank you very much, sir, for enriching our knowledge. I would also like to warmly welcome and thanks all our respected past president, office bearer, managing committee members, ICA members, student members, interior members, trade members and all our invited guests for their valuable presence and participation. I would also like to extend a warm welcome and sincere thanks to our representative of valued seminar sponsor, Kamdhenu Limited, Mr. Yogesh Sharma, Mr. Vinay Agrawal and Mr. Nikesh Maishurya for their generous support and valuable contribution in making today's technical seminar possible. We truly appreciate your continued association and support to ICA. A special word of appreciation to our lecture and seminar community team, Dr. Diaphragm Sevalia, Engineer Jay Shukla and Architect Jasan Shah for coordinating and conducting today's program so smoothly. I also sincerely thank our banquet committee engineer Varun Desai and engineer Shailesh Biyawala for taking care of hospitality and making all necessary arrangements for today's seminar. I hope that the knowledge shared today will be useful in our day-to-day professional practice and will encourage us to continue learning and sharing knowledge with one another. With this word, I once again thank our esteemed speaker, dignitaries, sponsors, committee members and all participants. Thank you.
Thank you very much, Narendra Bhai, for humble gratitude. Also, we are having vote of thanks.
Everyone. So, as someone said very well, कि सीखने की कोई उम्र नहीं होती है. So, I am not from the technical background. So, I am basically from the finance and marketing background. लेकिन आज यहाँ पे आके जो in-depth knowledge मिला है, great speakers सर से है, सभी लोगों से, तो ये हमें भी बहुत काम आएगा जब हम किसी क्लाइंट से बात करेंगे या किसी बिल्डर से बात कर रहे होंगे, क्योंकि इतना in-depth knowledge हमने आज तक कभी नहीं लिया था. But it's really great to come here, and I would like to say every time requesting this organization हमको ऐसे मौके देते रहें और हम यहाँ पे आते हैं. Thank you so much.